Yes, all right, I think we're live. So welcome everybody to our recently rebranded think tank from our normal hangouts that we have been doing. This week we're going to talk about teaching kids to code, and we're doing it in our brand new office, which we're super excited about, and we're doing it with a bunch of people that we're very excited to have with us today. I'll introduce them in a second, or I'll let them introduce themselves in a second. In the meantime, I'm Greg from Thinkful. I do operations stuff around here. This is Tatiana.
I'm on the growth team.
She's sitting in for Laura this week, who is in Florida, really unfortunately. And we have a bunch of really cool people with us today. So I'm going to start with Jeremy. Jeremy, you're on our left. So why don't you say hi, introduce yourself, and tell us a little bit about what's going on in your life.
Sure thing. My name is Jeremy Rossman. I'm one of the co-founders of Make Games With Us. We've been around for nearly 3 years now, and we teach high school and college students how to build iOS games. We've recently started piloting a new introductory curriculum for younger students, and just a couple months ago I taught a week-long intensive course for middle school students, 6th to 8th grade, 20 of them, and we went from never having coded before to having them with their own little clone of Angry Birds running on an iPhone. So I've gone through the sort of teaching kids to code thing quite decently recently. We also developed some introductory tutorials that were featured in the Hour of Code, and so I'm looking forward to having an awesome discussion on the topic and to hear what others have to think as well.
Yeah, awesome. We also have Lisa Conrad. Lisa, say hi and introduce yourself.
Hi, I'm Liza Conrad here with Hopscotch. Hopscotch is an app for iPad that kids and grown-ups can use to learn how to code and build really awesome things like games, as well as animations, stories, videos, etc. And we're all about inspiring kids to pursue their dreams and build whatever inspires them on Hopscotch, and really excited to talk with you guys and everyone else about what that looks like.
Yeah, cool. So Jeremy, you're here Jeremy, you're here with us as well. Tom, you're over at Scripted. I'm getting my names mixed up. Take a step and say hi. Sorry about that.
Hi, everybody. I'm Tom. I'm representing ScriptEd today, and ScriptEd is a nonprofit organization that works at getting in under-resourced schools to teach kids programming with an emphasis on HTML, CSS, and JavaScript, and getting kids in paid internships over the summer afterwards.
Very cool. And then we also have in the Thinkful office in another conference room, we've got Sam and Carl. Guys, why don't you say hi?
Hello.
Hi. Yeah, sure. So my name is Sam. I'm a Teach for America alumnus. After college, I taught math and programming to high school students, and now I'm back in grad school for computer science at Columbia, but I'm with Thinkful for the summer as a programmer.
And I'm here at Thinkful, and outside of Thinkful, I started the New York City chapter of Coder Dojo. Coder Dojo is a nonprofit that teaches kids how to code. They're usually 7 to 17 years old. It's very open and informal sessions. So Coder Dojo there's 135 chapters worldwide. New York City is one of the biggest ones. And we've welcomed over 2,000 kids to our sessions since 2007.
Yeah, way cool. So thanks everybody. The first question I want to start with is just like how do we get kids interested in doing this? I think a lot of times once you have somebody's interest, it's pretty easy to harness that and use it to drive learning outcomes. But what are some of the ways in which you guys get kids interested in learning how to code? And Liza, I'm gonna direct this to you since I imagine you're involved with some of the youngest of anyone here today.
Yeah, absolutely. I think it's really about the way in which we frame that question. So rather than thinking about how do we get kids interested in coding, I think it's about how do we get kids interested in building and then seeing themselves as builders and makers. And I know that word is a bit overused these days, but kids like to do things with their hands and with their minds and with their friends. So what we think is really powerful is helping kids see the connection between an idea they have or something they use and then giving them the skills and opportunity to do it. So we offer little tutorials, little starter games. Monkey Run is my favorite. that help kids see the connection between the blocks of code and enabling the monkey to chase the banana and try to get away from the gorillas. So I think by allowing kids to think of themselves as people who can build the things they use, that's really how we can pique their interest.
Yeah, cool. Tom, is that similar to what you do?
Yeah, I absolutely want to echo what Liza said there in saying that kids like working with their hands, and it's teaching skills, whereas a lot of school is teaching knowledge. And my background, I come from, I was once an industrial arts teacher, and it's funny how those two skills transfer very quickly from woodworking shop to computer programming. It's the same feeling you get when you've created something, whether it's physical in the real world or digital inside a program.
Cool. And then Jeremy, you look like you're getting ready to jump in, so
I think it's incredibly important to give kids a sense that they're going to create something that their friends can use. And that's the part that I think is the easiest way to make it tangible to them. And one of the things that we actually see is that games are a good way to do that, but they're not the only way to do that. Mm-hmm. And we're looking actually to expand our introductory stuff at some point beyond just games, because you get a lot of students who would have otherwise been interested in programming but who think that it's just for the nerdy gamers, and we actually want to show them that they can build things that they use, and that like the kinds of things they use, the apps that they're using day in, day out. You know, middle school students nowadays do have smartphones, do use computers, do have apps that they use that are not games, and to give them a sense that actually programming is the skill you use to build those things that their friends can interact with what they've created, I think is the most compelling pitch that we've been able to make. And games cover a lot of that, but it's also important to recognize that there's a segment of young students who should be into coding and who don't have to be into games, and we'd like to get them interested as well.
Yeah. Carl, over at Coder Dojo, what like methods do you guys use when you actually dig in and start getting people interested?
Yeah, I think so. To piggyback on what Jeremy said, one thing that I've noticed throughout our session is that the moment that a kid is able to have his code live, so actually have like a URL he or she can share with friends or family, everything clicks. Before that, it's this abstract, oh, I'm building my own adventure game, or I'm doing this thing on my computer. But once they have a URL they can ping people to, they feel like they own a piece of the internet. And we see such a difference in repeat kids coming back to our future sessions if right before the end we have them save their code and have them grab their own URLs. They feel like now that they don't just consume the internet, they're creating part of it. And I think that's really important.
Yeah, pretty cool. So, Liza, how do you position material when you're presenting it to younger folks? I mean, speaking as somebody who's involved in adult education, usually what we do is we say, hey, here's how you accomplish this task that you want to do. First we'll introduce an interesting task, and then we'll say, here's how you accomplish it. How do you introduce and position material when you're looking at it?
Sorry, could you repeat the last half of the question? It got kind of swallowed in the internet.
Yeah, sorry about that. I was just saying that when working with adults at Thinkful, the way that we try to introduce material is by presenting something that, like, finding out the goal that an adult brings to the course, and then showing them how to achieve that. That's how we try and introduce material. When you're working with kids, do you do it the same way, or do you introduce and position material differently?
Got it. I think kids like to start by doing and by working with somebody else. So what we're really focusing on right now is building our community and creating collaborative spaces for kids to try this together. So we start off by giving kids something they can play, they can interact with. We have a section where we feature cool projects that others have built. So we encourage kids before they start building anything themselves to sort of walk through the app and see what other people have done. And then they can download those projects and look at the code. So instead of just starting with a blank screen and bricks of code and trying to figure out, well, what do these mean and how do I put them together, they can walk through examples of other people's and play with them and then see, oh, okay, what happens if I move this sort of down the line, or what if I increase this number? How does that affect what happens? And then from there, starting really, really small. So giving them, one block and say, okay, what happens in our app we call moving make a line move with trail. So give kids that one small tangible thing and then build from there. But I think the really important thing is creating a space where they feel safe and confident and comfortable exploring, and a lot of that has to do with giving them people to explore with.
We found one of the most significant differences with our older students and teaching middle schoolers was that younger students, having grown up with computers their entire lives, have a more emotional relationship to technology and tend to personify their computers. And what that means is they tend, computers, they'll input the same actions in their computer, and they're used to getting different responses. Sometimes the computer behaves, sometimes it crashes, sometimes it slows down. And so when you're coding, it's somewhat deterministic. If you write the same commands, you get the same result every single time. And one of the things that took a couple of days to sort of get across to the students was that when their code was not behaving the way they expected, it was not the computer that was misbehaving, that they should actually look to their code and try to find the issue there. And adults are more accepting of the fact if you tell them, no, there's something in the process that needs to be examined, they'll believe you. Younger students are more skeptical. They tend to think, oh, well, the computer's misbehaving, or the computer doesn't like me, or something like that. And so actually an app like Hopscotch is extremely useful in helping them visualize commands they can understand without the obfuscation of syntax that you get once you start coding in a real programming language. And it helps them really realize that programming is about following a set of instructions, and that it's going to do exactly what you tell it to do. And so what we ended up doing is using an app called Lightbot, which was one of the games featured in the Hour of Code last year. On the first day, to show students, by analogy, we have this little robot, you're programming in commands, and that robot's going to do exactly what you tell it to. And if it runs off the platform, it's because you told it to, and not because the robot is misbehaving. And once we got that across on the first day, once we introduced more complicated syntax in Python and then Objective-C, the students were much more accepting that if something was wrong, they would try to debug it as opposed to blame the computer's emotions. And that was a big difference we observed, and something that I think if we had not noticed, we would have had a lot more difficulty addressing the younger audience versus the older audience.
I'll throw out there, I know plenty of professional programmers who will also blame their computer when they write bad code that has bugs.
Sometimes Node is just not set up well.
Sometimes it is. Of course, there is that one time when it is the computer, but when you're dealing with really simple pieces of code, it's important to understand what programming really is, and a visual interface like Hopscotch is actually very useful for that. So we're doing great.
And one small detail that I think we all forget is that kids can't type. It's really hard for kids to type out code, especially younger kids. So the most important thing for them to do is understand the fundamentals behind programming and some of these computational thinking and logic and sequence, and focus all of their energy and attention on these relationships, and then go on to worry about syntax and other things like that. So Hopscotch, for those of you who haven't tried it, is a visual programming language on iPad. So the code is actually a block. So you drag blocks of code and drop it in your editor, and that's how you tell the computer what to do. So kids aren't worrying like, oh wait, where's my spacebar key or my apostrophe?
Yeah.
It's similar to Scratch, isn't it, Liza?
Yeah, it's very similar. We're actually at Scratch conference today up at MIT.
Awesome.
Very nice. Yeah, so Hopscotch is visual. Scratch is another one. Thomas, what do you use with groups over ScriptEd to get them introduced to stuff?
So we work in HTML, CSS, and JavaScript, and I'm writing the curriculum now over again for ScriptEd to begin the next year, and I actually threw in just 2 days of Scratch in the beginning, which is something they haven't done in the past. And I threw it in because when I was teaching my class, we used Scratch for a very long period of time. And to me, I like using a visual blocks programming language for that first aha moment. And the first time that they really, a lot of these kids think that they're these great users of technology, or they are great users of technology, and they get compliments from their parents, from family members that say, you're so good with the computer, but they're great users. And I think that these visual block programming languages are the first time that they are a creator. And that is an important connection to make before going into the HTML but I do try to get them into the real programming languages as soon as possible.
Yeah, very cool. So, Jeremy, you mentioned getting people into Python and then Objective-C. Objective-C is a surprising one to me. I didn't expect to hear that. You usually start with Python and then move into more complicated syntax, or what approach do you take?
So, as we discussed earlier in this discussion, the most important thing to re-engage people and get them coming back into coding after whatever session you're doing is over is to give them something tangible that they've created. And we always try to work towards that. Everything we do is make something, right? And so for us, it was important to use these visual tools as an introduction, as I described, but also incredibly important to graduate to the real code as soon as possible. It's actually something we've seen be an issue even with courses at the university level. We talked to some schools, and they have their entire curriculum in Scratch, and students come out of that thinking that they know how to program, but they've never actually released an app. And so we didn't want to do that even to the middle school students. It turns out that once you understand the concepts with a good autocomplete like Xcode has, Objective-C, if you've never done coding before, is not significantly more complicated than, let's say, Java or C++. In fact, it's about equivalent level complexity. And so we did a Lightbot and other visual programming languages in the first day, and then Python on the second and third day, and then Objective-C on the fourth and fifth. And these were 6th to 8th graders. Now, noted they were talented ones, I'd say, but they were at a public middle school. It was not like a charter school or something like that. It was not a magnet school. They were the ones who signed up for the course, so they were definitely interested. But I think people have overestimated the complexity of Objective-C. We really don't see issues with that. We are able to get people through the syntax quite rapidly. We have an hour-long workshop where you can build Flappy Bird in an hour in the browser. We have a sort of clone of Xcode that runs in the browser. We've done these to young students all over the Bay Area, and with great success. Now, again, a function of whether they come back later and try to re-explore it, and that's why it's important to get them to actually create something they can share. But people are used to Java, and they teach that by default, and so they think maybe that's less complicated. But if you look syntax per syntax item, Objective-C is really no more challenging.
Yeah, very cool. So you mentioned keeping people engaged in between sessions. This is a question that I really like to hear from Thomas and Carl on. But you guys do, I think, right, like kind of session-based learning. How do you keep kids interested in sessions? What types of resources do you direct them to work through on their own?
I'm sorry, could you repeat that? I lost a lot of it there.
Yeah, sorry, it seems like our connection is a little poor, I apologize. I was asking specifically to follow up on Jeremy's point that keeping people engaged in between meetings is really important. And I was wondering what resources you guys might use online or otherwise to keep kids kind of interested and engaged in between meetings at Dojo or at ScriptEd.
Well, we try to do all our work in the cloud. We use Cloud9. It's a IDE that allows kids to view their code right away. There's a terminal right there, and the reason we choose that is because a lot of these kids go home and will work on it in their free time, which is great because I think there's a lot of classes in school where you're trying to assign homework and none of the kids are doing it. But when it comes to computer programming, I find that if you don't have a formally graded homework, the kids will still go home and work on it and think on it. And for example, when I was teaching high school, I had every single kid in the school took my computer science class. They didn't choose to be in it. They all were in it, boys, girls, everybody. And I never assigned a formally graded homework, but I had one of the better percentage of homework being completed in the school because the kids were going home and they're on the computer all the time. And if you give them the option or the access to use their computer in a way that is productive, it's something that their parents are more likely to let them use it in the afternoon.
Yeah, very cool. Carl, do you have any? So Cloud9 is awesome.
You spoke about engagement, and I think one key part for us in between Dojo sessions, because they happen once a month, is get them really engaged at the session. And the way we do that is really, for a kid that's interested in technology, being surrounded by other kids that also like technology, it's kind of this liberating moment. Because oftentimes they feel like they're alone and that they're different than other kids. But then when they realize there's a room of 100 kids that are just like them, that love being in front of the computer doing things, they just feel like they belong. And so another way to make them engage is make them work on projects where they get to choose what the project looks like. So an example is like make your own adventure game on HTML and CSS. If the kid's building a narrative, and so when he finishes the session, he wants to go home and continue working on this narrative because he's now at the treasure part of the narrative, and he wants to see what happens if you get in the cave or not. So if they have ownership of the project, they're much more likely to spend more time outside of the session.
One thing that's really important too, you mentioned you want getting people in a room with a bunch of peers and then making them realize, oh, I'm not alone. We found the younger the student, the more important it is, especially for girls, to recognize that there are other girls who are interested in CS and have good role models. And it was something that was I actually sort of got, I'm not yelling to do the wrong word, but got upset at the school administration because they created this app development class. They asked me to volunteer to teach it, and I had no involvement in actually setting it up or marketing it in the school, and ended up being 18 boys and 2 girls. And across the hall, we had a babysitting intensive class for 1 week that ran in parallel, and it was all girls. And I was just going, wow, there was such a missed opportunity to position it in such a way to show the girls that this would be interesting for them to do. And so many of them, when I asked who does better in math at the school, who's more interested in the sciences, I was told by the teachers it was mostly girls. And so there was a huge sort of failure in actually showing all the girls who were actually interested in science and math that there were other girls also interested in science and math and getting them all in the same room to code together. And so if I were to do it again, I would make sure the administration was aware of that and also make sure that we always have instructors who are women so that these girls know that when they grow up, they can be like X instructor who's really fantastic. And we have several women this year on our instruction group for our boot camp because we thought that's a really high priority for us to make sure that the women can see that they have something to aspire to and that they're not alone.
Yeah, Jeremy made 2 really important points. So before Hopscotch, I worked at Girls Who Code, so I'm very familiar with this issue. So the first is exposure. Girls are better at math and science and often more interested in math and science than boys in middle and elementary school, but something happens when they start high school where they start to think, wait, I don't want to spend all my time in a basement with a bunch of dudes who haven't showered for 2 weeks eating stale pizza. So that's the image they see in society. So I think programs that start earlier are really important because they can intervene and help dispel that myth. But almost more importantly, girls need to see images of women succeeding in the field who look like them. So bringing in women as instructors or just mentors, role models, etc., who are doing really awesome things with technology is really powerful. An important component of that also is helping them see that computer science in particular and coding in particular are ways to change the world and to help people, because you don't see the drop-off numbers in chemistry and biology and math that you do in computer science. And a lot of that, I think, is because girls want to help people. So they think, oh, I'm going to study biology so I can become a doctor, or I'm going to do this thing so I can, help massive amounts of people all over the world. But in fact, technology is one of the most powerful ways to help people and change the way that we live our lives. So I think that any effort we do to specifically bring girls into coding needs to be tied to very concrete examples of how coding changes the world.
So, go ahead.
That was all. I just strongly agree.
Yeah.
Another thing I think is important when you're thinking about boys and girls in a class, a CS class, is I don't think there's anyone, or there's not many people out there that are instructors, I think, are trying to exclude girls, but maybe doing it unintentionally with the project that's being created. I mean, if you're making a program that's, build a Pokedex for a Pokemon, usually those are boys playing Pokemon, whereas you got to try to find a majority of players of Pokemon. But you have to be conscious of the program you're creating, and is that something that is going to appeal to the girls, or are they going to feel like it's a basement with guys eating stale pizza? So you just have to be conscious of everything, every step you make.
Yeah, yeah. Sometimes you might make a Street Fighter-based project as well. Yeah. So another question that I have for the group is that there may be folks watching that who are not in New York City, don't have awesome groups like Dojo and Scripted that they can go join in person. So they're relying on online options and on apps that they might be able to download and on things that they can do maybe with the they're working with directly. For people like that, what approach do you recommend to talk like outside of a formal structure? If they don't have an option at school, if there isn't a local group like Dojo that they can go to, how do you get kids interested and how do you spend your time with them?
Well, I'll make a shameless plug for Hopscotch here. You can download Hopscotch today for free at the App Store to your iPad and start coding immediately. Anyone can download it. Anyone can give it a shot. We actually have quite a few adult Hopscotch users, myself included. And anybody can try it out. We're also encouraging people to start clubs. So if you have, you want to learn Hopscotch or you want to learn how to program and there isn't a group in your school, in your community, you can get a bunch of people together, download Hopscotch, and try working on it together if you feel like that group supportive environment will be more conducive to learning for you.
Yeah. And Carl, you started a group or helped start a group here in New York. I imagine that's something other people can do as well. Do you have any advice for folks interested in doing that?
Sorry, can you repeat the question? It's cutting off.
Yeah, sorry. You were involved in getting the Coder Dojo group started in New York. If people were interested in doing that elsewhere or in starting another group in their area, do you have any advice for them getting a group started for kids learning code?
Yeah, absolutely. One thing that you'd be surprised is how willing developers are to help start those groups. The community really, really, really thrives when it comes to teaching kids how to code. And there's tons of resources that are absolutely free out there. Hopscotch, I love it. You guys should try it. Scratch is another one. We have all of our sessions include Scratch because kids love it. Some schools teach it. And really, if there's, no matter where you are around the world, find any technical company and speak to the programmers, and I guarantee you'll find people to volunteer and to help out and to help get things going. And then it's a snowball effect. Once we get, our first session at Coder Dojo, we had 3 kids, 4 parents, and 7 volunteers. Our last session, we had almost 100 kids. It'll pick up very, very quickly.
Yeah, yeah. And then Thomas, does ScriptEd exist outside of New York as well? I should know the answer to this, but I don't.
It doesn't, but there might be plans for future growth. And as far as the industry and people volunteering, it's nothing short of astonishing how many developers, programmers are willing to volunteer their time to teach kids how to code. I didn't see it coming when I first entered into the CS industry, into education CS. There's so many people out there, so many programmers, so many developers that want to volunteer their time to teaching kids how to code.
Yeah, it's something we see here at Thinkful. I think the mentors who get involved with us love what they do and want to share it with other people. And I think that's even more true when you're talking about this learning. So Jeremy, we're running up against our time limit. Sure. Give you the last one here. How should people go about helping the kids there, in their lives, like learn how to do this stuff?
I think exploring, what industries one might want to work in, and then realizing that almost all those industries now have a software development component is very motivating. When I tell people the New York Times now has a large software development team, people look at me like, no way, and that wasn't true even just a few years ago. And so picking something to work towards, I think, is very, very useful and motivating. And then beyond that, Google is a fantastic tool to find your local meetups, boot camps, groups that you can attend to pick up those skills. But it's really helpful to know I'm picking up these skills because I want to do X, programming or software development work for Y industry that really fascinates me. And even if you're interested in biology or chemistry or research, it turns out that knowing how to code has very powerful applications nowadays. And so that's what I'd say is a good place to start. Is go learn about all the ways that the things you've always been passionate about can actually be revolutionized or improved by by programming and learning to code. And then once you're all fired up, explore your local community, find the meetups, and then use the introductory tools like Hopscotch, and maybe graduate to coding content online. Come to one of our our online courses or boot camps, of course. And there are many others now. I think the options have exploded in the past year. So I think it'd be hard pressed to find a city with more than like 400,000 people in it that doesn't have a coding boot camp running now. So there's a lot available.
Yeah, that's awesome. So I'd just like to take a moment and thank everybody for joining us today. This has been a lot of fun. Thank you all for hanging out with us. And we'll be back with another topic next week. So until then, take it easy.
Bye.
All right, thanks for having us.
Thank you.